And we're live! Welcome to another edition of RockSim Live. This is actually live. I am doing this. It's 2 p.m. Mountain Daylight Savings Time here in Colorado. And my name is Tim Van Milligan, and this is where we're going to talk about RockSim and RockSim Pro and the launch visualizer. If you have questions, I have the chat going on right now in YouTube. And go ahead and put those in there anytime you want. We've got a number of people that are already here. We have Dennis Rainville, we have Maximo, and James from North Dakota, and Art Applewhite from Kerrville, Texas. And more people are coming in all the time. This is cool. We got some new names that I have not seen before, so welcome. I do have a monitor right here where I'm looking off to the side. That's what I'm doing. And I got my computer here, and the fan is already going, so we're heating up here. All right, so if you are new to RockSim, let me show you my screen here. There it is. All right, so this is the Apogee website. This is where you'll find RockSim. It's apogeerockets.com is our URL. We have this scrolling banner bar right here, and one of the banners is always for RockSim. So if you click on that, that will take you to a place where you can download RockSim. And if you scroll down a little bit, down on the page, on the home page, right here it says free RockSim training every week. That is what we're doing right now. And if you click on the image, it will take you to the page where we archive the previous episodes. And we are on episode number 142 today. Last week was 141. Last week we talked about how to create a template for your fins in RockSim, which was pretty cool. It's pretty simple, but pretty cool. How to print out a list of your simulations and the wind table in the launch visualizer. All very neat stuff. So if you're interested in what we've talked about before, maybe you have a question and you're not here live, maybe you're watching this on replay, I would come to this page and then do a Control F on the keyboard or Command F on the Macintosh, and it gives you a search bar here at the top where it will search only this page. So if you wanted to do clusters, it tells me that we've talked about it 14 times, and then you can go through and just see, choosing motors for clusters, changing a motor mount to a cluster, all kinds of times that we've talked about clusters, and maybe your question might have gotten answered there. And then you don't have to wait until next week to ask your question in the RockSim Live. So this is a good place to start if you're just joining us. Another good place to go to is you go to How To and Guides, click on that, close this right here. And then that brings up this menu, and then over here there's one called Software. Click on that, and this will be more specific to RockSim. Here's the free trial that you can download. What is RockSim? Maybe you're brand new and you don't know. Some of the features of RockSim, the frequently asked questions, what you can do with RockSim, system requirements, version history, things like that. We also have official training videos that you'll find here, the RockSim video tutorials, the RockSim live training, which is what we're talking about right now. And we also have RockSim Pro tutorials as well. All right, so that is kind of the basics that we go over every week just to get everybody caught up. If you haven't downloaded RockSim, go ahead and do that. Let me check the chat here. Oh boy, a whole bunch of people came in here. We have Fat Bank, also from Texas, coming in. Terry Wheelock is here. Yeah, and we had the first question. We had Maximo says, is there a limit of a stage rocket and how I make a GPS in a model rocket? And Dennis was already answering that question for him. Thank you, Dennis. And Dennis is correct. He says 3 stages is the max for RockSim. And that is true. And we did that because the NAR in EEE, that's part of the safety code. You're limited to 3 stages. Because what happens is, because our rockets are not steerable, they weathercock into the wind. So they just gradually turn into the wind, and the longer the rocket flies, the more it will turn into the wind. So eventually, it's going to be going horizontal, and then gravity is going to start pulling it downward. So now your rocket, instead of going nice and straight and up where it's safe, is going horizontal, and you don't know where it's going to land. So 3 stages is a safety limit. There's a way to trick RockSim to do on a 4th stage, but it's pretty involved. It involves going into the motor database and creating fake motors. That's a really advanced topic. I don't know if we've ever talked about that. And then he asks, how do I make a GPS in a model rocket? Well, basically, you need, our rockets are non-steerable. When you start getting into steerable rockets, then the government wants to know what you're doing. Because now you can turn it into a weapon, and we're not here to make weapons, we're here to enjoy the hobby. But we do use GPS in model rockets. Basically, we use GPS to find out where our rocket went, and so that we can track the rocket, so that we can find it. And we sell a GPS tracker on the Apogee website. I'll just show you where it is. So if you go to the shopping menu right here, click on the shopping menu, then come down here to electronics and payloads. Click on that. And here's the, oh, look at this one. I'm missing an image right there. But here's rocket locators, because basically that's what a tracker does. So you click on that. And the first item here is the simple GPS tracker. And then we also have the tele-GPS, which is also can be used as a tracking device. This one just transmits the rocket's location. This one, I think, also transmits the rocket's altitude. This transmits altitude as well. It's just figured out based on what the GPS position is of the rocket. Oh boy, I'm missing some more photos. I gotta get those photos up. Shouldn't be missing photos. But the simple GPS tracker is an Apogee product. And we tried to make it as simple as we could. It's a handheld device. This is the part you hold on the ground, and it's kind of like has a little compass indicator here. And you can see right here, if you can just see it, there's an N for north. So north is off to the right. And the arrow is pointing that way. So that's the direction you need to walk to go find your rocket. It will also show you the actual GPS longitude and latitude coordinates if you want to see those. But if you just walk to where the arrow is pointing, eventually you'll get to your rocket. And this is the transmitter part that goes inside the rocket. This little component here on the end is the antenna that transmits. These wires here are for the battery, so you can connect it up to whatever power supply you want. The handheld receiver is also backlit, so if you launch your rocket late in the day and all of a sudden it's night and you still haven't found your rocket, it's backlit. So as long as you don't trip and fall, chasing your rocket, you can still find it even at night. And how small is it? Well, it will fit into a 29 millimeter tube, which is just over, about 1.5 inches or 1.25 inches in diameter. So that's what the GPS tracker is. So if you're interested in tracking rockets, now if you're interested in doing more with GPS, we do sell another device called the Telemega. Again, go under electronics and payloads, and it would be under dual deployment. And we might not have them in stock right now, but let me see if I can find it. Right here, Telemega. And this is a flight computer. So what it's meant to do is to do things so that you can program it like a computer and it can perform various things. And since it has GPS on board, you can tell your rocket to do certain things at certain coordinates or certain angles of attack or whatever. But you do need to program it, and programming it, I don't know how to program it myself, so that would be totally up to you to learn how to do that. So hopefully that answers Maximo's question. Alfred Indy says, Tim's advertising forced me to spend more money on the Kronos. I simulated the Kronos on an iMotor in RockSim and it said it was safe. Any reason we should not use an eye in the Kronos? So let me bring up the Kronos. This is one of our newest rockets. So if you just go here to the search bar and you can just start typing Kronos. Oops. Come on. Kronos. And it will pop up and it will bring you to the Kronos page. And you can click on it, and that's what it looks like. This was launched with an H motor right there. That's what it looks like on the pad. It has a nylon parachute. It's a 3-inch diameter rocket. It's pretty big. It's, 3 inches and about 51 inches long. So that's kind of the size of it. You need to fly it off of a launch rail because it has rail buttons. Someone asked me if you could put it on a launch rod. Basically, you'd have to put launch lugs on it. And my answer to that is you could do it, but it's not recommended. So what happens when rockets get big, big in diameter, they're sitting on the launch rod. And because they have such a big diameter, the wind blowing across them, it's kind of like it's a big sail. The bigger the sail, the more it wants to move around. So your rocket, while it's sitting on the launch pad, could be doing this on a rod. And we don't want to do that when we launch the rocket because we don't know which way it's going to go. So that's why we launch it off a rail, because a rail is much stiffer. And so we know which direction it's going to go. So that's why we put launch buttons on this rocket so that it's nice and sturdy. So when you launch it, it goes in the direction you want it to go. Yeah, so I would recommend keeping it with the rail buttons on it. This is what it looks like when you get it. So the question is, could you launch it on an iMotor? And what I think I'll do is open it up. Well, the short answer, Andy, is yes, you could fly it on an iMotor. We only simulated it up to an H because they start going pretty high on an H motor. It's a lightweight rocket. It has a 29 millimeter engine mount in it, so it can take 29 millimeter motors. And there's a 29 millimeter J motor, and there's enough room inside it. You could put it in there. I have to think about that. I have to find out how long a J motor is. I'm pretty sure the I will fit. The Kronos. Let me bring up that image again. It has an engine ejection baffle that's like right here where this red band is. So it can take a pretty long motor but if it's too long, it's going to bump into that baffle. So that's kind of like the limiting factor on how big of a motor you can get in there. This is an 18-inch long tube. Let me go to the J motors. So if you go to shopping and you go to Rocket Motors, 29 millimeter motors, and I'm going to scroll down to the bottom of the page because there's this chart. And this chart here, I can sort, and I'm going to sort it by J motors. And then it resorted the charts, and it didn't find any J motors. I thought there was a 29 millimeter J. Maybe it's a 38 millimeter J. So there's the H's. Here's the I's. Okay, so the I, the maximum length is 365 millimeters. Let me get a calculator out. I don't think that's 18 inches. 365 divided by 25.4 is 14 inches. So an I motor is 14 inches long. So that's going to give you, and the tube coupler that the baffle is 4 inches long, but 2 inches hangs down. So there's basically 2 inches between the front of the motor and the back end of the baffle. That's probably enough room where you're not going to blow up the baffle by hitting it with a strong ejection charge. If you're going to do that, I would put like a thick layer of epoxy on the bulkhead, on the back bulkhead of the baffle to protect it. The epoxy is pretty flame resistant. You'll get sooty, but who cares? Nobody will see it. But the other reason, like I said, this rocket's going to go really, really high on an I motor. So let me open up the launch visualizer, and we can actually take a look at that. So we get a new window here, and we'll go open up the launch visualizer. Which is RockSim.com. Let's see if I got the whole screen on here. Okay. So I need to log in. So I'll log in right here. And I'm going to put my email here and sign in. And I have loaded in my launch visualizer, in my space reserved for me, I have already loaded in the Kronos. So I can just type in Kronos. Oops, if I spell it right. There it is, Kronos. Load that up. And it loads it here, and it's going to redraw it here in just a second. And then we can simulate it, what it's going to look like on an I motor. So that's the Kronos. We have to select the launch site. The default launch site is my home launch site in Pueblo, Colorado, just outside of Pueblo. It's a nice field. You can see our flight line right there. Here's all the pads. These are the H and I pads right there, so that's pretty close to that. So we'll leave that. We'll give it a starting state. Let's go straight up, and we'll say a 5 mile an hour wind. Let's make it 5 miles an hour. Coming out of the west, click OK. Okay, so now we're going to load the motor. See, what I'm doing is just going down the list here. And this is where you load the motor. And it's just like RockSim. You choose the engine. And I want to get down to I'm going to grab the little scroll bar here. Get down to the I motors. Okay, so we got a Cicerone, I don't know, we'll go on I-204 Impulse Max. This is a really high total impulse. Here's one that's even higher. So, there's an even higher one, but this is, let's use that one. I want something that's going to go really high, just to kind of show you. The ejection charge, I'll say 13 seconds, that's the maximum. Click OK. And now we'll simulate it. We'll just click the button down here to simulate. It's going to use 385 credits, and I have 91,000, so I'm okay. And we're launching, and it's running the simulation in the cloud on the servers. And when it's done, which is what it's doing now, it's going to redraw the simulation. All right, so it's got to redraw the background. It's got to load in the map in the background. So if I zoom out, just by zooming out with the scroll wheel of my mouse, again, there's that flight line. I'll change north to the top, so we're kind of orient ourselves. Okay, so north is straight up, but our rocket is actually pointed straight up. So if we look at it like straight down, you can see we're pointed straight up. And then we will go and do a launch, and you can already see here it's going to be in the air 194 seconds. So it's taking off, and it's going, zooming high. This blue smoke means it's coasting now. And we're already at 3,000 feet and still going. Okay, we're getting close to the top. And there's the apogee point right there, about 3,600 and something feet. And now the rocket's going to come down, and this is going to take a long time, so I'm going to zoom out a little bit. Try to get the lay of the land here. Our launch site was right down here. Let me turn on some indicators here so you can get this better. So I want to see the trajectory path, and I want to extrude that path that's in the air all the way down to the ground so we can see where it is on the ground. And so that's what it looks like right now. It kind of looks like a curtain. And if I take the time slider here and I slide it all the way to the end at 194 seconds, we can kind of see where it's going to land in relation to where we launched from. So we launched from, see this green line that's weaving its way through here. That point here on the ground is where we started from, and it lands way over here about 1,200 feet away. So that's actually better than I thought. I thought we would be like way out here. But that's a quarter mile away. So that's a pretty good walk. So yeah, you could fly it on an eye. It should be strong enough. It has plywood fins. They're through the wall. The rocket also has strakes on it. So what's a strake? If I go here, see if I see these long fins here along the side of the rocket. One of the reasons this is such a strong rocket is because of these strakes. Usually the weak point of the rocket is right in front of the fins. And what we've done here is we put these strakes on, and they go all the way up. Like I said, there's a baffle in here, so the baffle actually extends up into this top tube way up here. So we've really stiffened this tube up a lot by putting these strakes on. And that's what makes the rocket, you know, strong, but it is pretty light because it's 3 inches in diameter, and we call it a thin wall tube. It's actually more like a medium wall. You know, if you think of a BT-80, which is 2.6 inches in diameter, its wall thickness is like less than 0.02 inches, where a 3-inch tube is probably triple that thickness. So it's a lot thicker. It's not as thick as a high power tube, but it's much stiffer than what you'd think. Okay, so hopefully that answered Alfred Indy's question. Let's see what else we have. Okay, people are talking back and forth. Let me see if there's any questions. Maximo says he needs the GPS in his model rocket because I launched with my dad and land on another house, and when the men's house where the rocket landed, it will be super angry. If you want to keep your rocket out of somebody's land, then what I would recommend is the gliding parachute. That's this right here. With a gliding parachute, this is kind of what it looks like. It has a remote control, which means this is actually RC controlled. So that controller has a little servo in it, and it pulls down on the lines on this specially shaped parachute, and you can actually steer it. And the advantage of this is that you can actually penetrate into the wind. So normally the rocket wants to drift with the wind. This means you can fly into the wind, and you can actually steer it down and try to get it to where you want to land. And you know, in fact, I call it the come to me recovery system. So come to me, rocket. Don't go over there. Come to me. And you can attach it to pretty much any rocket that is bigger than a BT-80. So this rocket here is a BT-80, which is 2.6 inches in diameter. This would easily fit in the Kronos, which is 3 inches. We've flown them in up to 4-inch diameter rockets. And so the advantage there is you can get it to come back without losing the rocket. And you don't need the GPS because you're just going to steer it right back to yourself. So if that is your goal, that's what I would recommend. I got this stupid thing here, a pop-up on my thing that won't go away. Go away. Johan says, thanks for the response on the pictures of my models. You must have enjoyed it. Yeah, I don't remember which pictures, but yeah, people send me pictures all the time, and we do like seeing them. It's cool. Fatbank says, I'm considering a 3-inch Nike Smoke equipped with dual deployment. Is it possible to configure head-end deployment in RockSim? And the answer to that question is yes, because RockSim doesn't care where you put your electronics or the parachute. Like in this rocket, it's almost head end. Head end means that you're putting the electronics inside the nose. Where normally in a dual deployment rocket, the electronics is like right in the middle. And there's an advantage for that because it allows you to use the motor's ejection charge as a backup. When you're doing head end, it's a little bit more complicated, but it can still be done. But RockSim does not care. So if you did a Nike Smoke, let me see, where's my RockSim? File, open. Do I have I should have a Nike Smoke in here. Okay, I'm looking for something that ends with .rtk or rkt. There's a Nike Smoke right here. Here's a 4-inch. Save my changes, and I would say no. Okay, so here's a Nike Smoke, and I understand he probably wants to do head-end deployment because the Nike Smoke is actually fairly short rocket, but it has this big long nose cone where you can put electronics in, and RockSim doesn't care. So on this particular rocket, we have 1 parachute, and to do dual deployment, you need 2 parachutes. I'm seeing my center of gravity like way up here, and I'm wondering why that's going on. And it says use the values here, so I need to uncheck that. So then my center of gravity goes back here. And if the center of gravity symbols are too small to see, go to the Rocket Design Attributes tab and change the side view marker size, which is, we're looking at the side view, and the markers are these. And I'll make it 1.25 inches in diameter. And did it make it bigger? Not really. Oh, this one. 1.25. There we go. See, it made it a lot bigger. So we have one parachute right here. To do dual deployment, you just add another parachute. So this first parachute is probably a pretty big. It's 35.6 inches in diameter. We'll call this one the main parachute so we can tell them apart. Okay, so I got one parachute in there right now called the main parachute, and I can just simply put in another parachute. And this one's going to be a small one. So we'll make it, I don't know, 15 inches, make it nylon. And if I go to the side view, I can see where it is. It's showing it like right here, right now. Let me move the location back here. Let's change the color of it so they're different colors. Let's make this one a red one, both in 3D and in 2D. Okay, so there's a red parachute and then there's a blue parachute behind it. And now when we go to launch, so you go prepare for launch, and you're going to select the rocket engine, and I'm going to choose an engine. This is a big one. So let's go with a J135 and make it 14 seconds. And click OK. And then under the flight events, this is where you have your two parachutes. So we have the main parachute, and we want to say that one this is dual deployment, which means they're going to come out at different altitudes. So for this one, we'll say deploy at maximum ejection delay. So this one is the maximum ejection delay was, I think I said 14 seconds, 13 seconds, 14 seconds. And then the smaller parachute, let's deploy that one at Apogee. So the electronics is going to sense the altitude, and it's going to sense Apogee, and it will deploy it at Apogee, and then at 14 seconds into the flight, hopefully, which is after Apogee, it will deploy the main parachute. So then we can just go to the flight profile and take a look at it and see what happens. And it goes pretty high. It goes 5,340 feet. So this is kind of like an animation of the flight of the rocket. And this is kind of like the launch visualizer, except for this is 2D, where the launch visualizer is 3D. If you want it in 3D, it's really easy to do to export it and open it in the launch visualizer. So it's coasting upwards. It had a really long burn. And like 53, okay, so now 53, and it's coming down. I must have very little wind, so it's coming down real slow. And at, well, we're already at well after 14 seconds. So the main parachute came out at 14 seconds, and I don't know if we got the Apogee or not. So it's 14 seconds after engine burnout. So whatever the motor burn time was, and you can actually see where engine burnout is. It's like where the smoke stops. So somewhere like right there, the motor burns for 6.8 seconds. And then 14 seconds after that would be in the 20 seconds. That's when the main parachute is going to come out. So we got the drogue and then the main parachute, which you can't really tell the difference in this. But it popped out, and then the rocket's coming down nice and slow. And 204 seconds later, it's on the ground. So I'll show you how to save that to the launch visualizer. So go to, I'm just going to save it on my desktop first, because you got to save it on your computer, and then you're going to upload it to the cloud. So I'm just going to put it on the desktop, hit save, and then I'm going to go to the launch visualizer, which was in Chrome. I think I had Chrome still open. Yep, there. Okay, so we're back in the launch visualizer, and then just click upload new rocket. You're going to browse your computer for that rocket, and I put it on my desktop. There it is, the 4-inch Nike Smoke. Click open. and then upload it. And when it's done uploading, we'll see it here. Okay, so there's this Nike smoke sitting on the pad. And I'm going to go to the flight, or my data. And this is that one that we just did. So I'm going to highlight it. And I'm going to hit load engine. So that's just going to automatically load that J into the rocket motor. You can see it's the J135W. And we have an ejection delay of 14 seconds. And what I want to do here is just verify that that 14 is not long enough. And I probably, instead of using the ejection charge to deploy the parachute, I probably should have used the electronics to also deploy it. So what I should have done was to deploy it at an altitude, and that altitude, you know, maybe 600 feet, so that the rocket's not in the air over 200 seconds. Then the other one will be, again, deploy at Apogee. And as before, we're going to be launching from that launch site in Colorado, so I'll just click launch. It remembers where we launched from, and I'll simulate it. Ugh, that's a big long motor. It's sticking out the back. This one's in the air only 23 seconds, so let's go see what happens. Rocket take off. Oh, it went unstable. It didn't like their engine hanging out the back that far. That was interesting, right? Let's back up and see that from a different perspective. Oops, not that one, this one. So the rocket was sitting right there on the pad. And it took off, went straight for a little bit, and then it went unstable. It's flipping over and over, and then the parachute came out, and holy cow, it's going upwards. Or is it going sideways? It's doing something weird. I've never seen a parachute come out and then go vertical before. There's something wrong in that. That's interesting. The rocket goes unstable, and that's where the parachute popped out. And then when the parachute popped out, it went up. It went up really fast. It caught a big thermal. Let's see if we can figure out what might have happened. Let's go to the engine here. And engine overhang. We got hit 12.7 inches. That's why it's hanging out so bad. Let's go here to my units. So under my data, units. I want to leave that in inches. I only wanted a ½ inch, so I wanted to go. Okay, so here it is at 0.5 inches. I should be able to select that, 0.5. Hit tab. And now let's launch. See if that changes anything. Let me see any other questions while we're doing this. Maximo says, I'm 8 years old. Is there a rocket for 8 years? If there's not, so supervision with my dad. And yeah, you want to have your dad there with you. Yeah, so now here the rocket is flying just fine. And we're at almost 8,000 feet. And it's definitely going straight up. So yeah, don't hang the motor out the back end of your rocket so far. Otherwise it does crazy things. And you can see my rocket is way up in the sky. And it's coming down, and I'm going to speed things up here. It's just my computer's acting a little slow. Come on. I wanted to see where that parachute came out. Yeah, so Maximo, definitely get adult supervision. If the only thing that flying a rocket for an 8-year-old, I would say maybe a water rocket. We do sell a water rocket set. That would be okay for somebody, but I would still, you're pressurizing a bottle, so it's still not something that you want to do without adult supervision. So here's that Nike Smoke, and you can see this is the classic shape of a dual deployment rocket. Let me turn off the extruded flight path. Okay, so this is the trajectory. It launched here, it went up, and it was coming down fast, and then you notice there's a dog leg. It changes trajectory, and that occurs when the rocket's 600 feet in the air. So right about there, and that would be 600 feet in the air because that's where we set it to come out. So the answer to your question is RockSim doesn't care where you put your electronics and how you arrange the parachute to come out. It doesn't matter if it's a head end or deployed from the middle. For dual deployment, it will do it just fine. Johan says, curious what the main rocket delay will do. So when you're doing dual deployment, if this rocket did not go that high and this point here happened before 14 seconds. So it was like 6 plus 14, about 20 seconds into the flight, the ejection charge of the rocket motor is going to come off, or it's going to blow out. And normally it blows through the tube and pushes the parachute out. If there's no parachute in front of the tube because the parachute's already open, so basically the rocket is just hanging under the parachute, and then it just fires an ejection charge through the tube, and there's nothing in the tube, so it just goes out into the atmosphere. So that's what happens when the main ejection charge goes off and the parachute's already out in the air. And that's why it's a good backup, because if the electronics fail, now your parachute is still inside the rocket, and when the ejection charge goes off, now you're going to get an extra kick to kick it out. So that's why we like to use the motor's ejection charge as a backup. But typically they do fire when the main parachute is already out, because that's what's supposed to happen. And then it just vents into the atmosphere, no harm, no foul. It makes a nice little poof, and people get all excited, and that's cool. It's a great spectator event. Johan asked, Tim, can't you make those visualizations faster, more frames per second? I think that would really improve the presentation. And you're right, it would. But the downside is, see all this, this background stuff? That background has to be loaded. It has to be downloaded to your computer at the same time it's running the simulation. So if I go here to this view, so we're gonna, I lost the view again. And I'm gonna turn that one off and just zoom out a little bit so you can kind of get the lay of the land. Let me start this over again, right? Get back here, go back to 0. And the reason it's slow is because it had to load that map in the background, all the terrain in the background. So when the rocket takes off, it has to load all that stuff in the background. And at a higher frame rate, it has to load it faster. And what it does is it actually bogs down your computer, and it even though it has a higher frame rate, it can't. It depends on the horsepower of your CPU, and it also makes the simulations run slower on our servers as well, because right now I forget what the frame rate is, but if we have to run more frame rates on the server itself, it slows them down as well, and it causes more CPU time, and then we'd have to charge more for it. So this frame rate that we have here, it looks a little jumpy. You know, you can see it. This was, we had to make a decision on the frame rate, and this was the best compromise that we could come up with. I wanted a higher frame rate myself, but the programmers, they said, Tim, if you go with a higher frame rate, you're going to have problems. So here's the rocket hanging in the air right now, and if I click on it, you can see it's not a nice smooth coming down like my mouse. It jumps from 1 second to the other 80. It's every half second. It draws the rocket. You can see that right there. That was a good question, though, Johan. Let me see if there's any more questions. Maximo says, can I put a cockroach astronaut into his rocket, or an ant? Sure. We like to use insects because insects have an exoskeleton, so they can survive the high G-forces of launch. Just don't use mammals or reptiles. They won't be able to handle them, and it's just very traumatic for them. So that would be my advice. Just don't use those. Where are we? I don't see any other questions. We still have a few minutes left. There's a lot of talking back and forth. 462 Tool says, didn't you work on the Delta rocket? Could you tell us what area you worked on? That sounds interesting. Yes, I did work on the Delta rocket. If you go to How To and Guides and then go to the About, maybe our history. I'm sure, I think I have a picture somewhere with me in front of the Delta rocket, so it's not under history. About, maybe it's under philosophy. Yep, there it is. This is, has to be around 1992 or 1991. And this is the crew of the Delta rocket from that time period. And this is Launch Pad 17, and that's 17B. 17A is over here on that side. They tore these down now because the program is done. So when I worked there in Florida, this is Cape Canaveral, I was a launch operations engineer. So what that meant was there was different engineering, and there was like propulsion engineers and mechanical engineers and electrical engineers, and then there's launch operations engineers. And so our launch operations is kind of like the umbrella to everything else. So we would make the schedule, and then we would interface with the other engineering disciplines to meet the schedule. So we would say, okay, we got, and basically the schedule was determined by the customer. Like if you wanted to go to Mars, with sending a satellite to Mars, you have to launch in a certain window when the Earth and the Mars are in the right positions in orbit around the sun. Because if you launch at the wrong time, it's either going to take you more fuel or your rocket's never going to get there. So the customer would tell us when they wanted to launch, and then based on that, we would come up with a schedule and work backwards to where we would have to set up the rocket. So when I first started there, I was not at the launch pad. I was in a facility called the Delta Mission Integration Building, or DEMCO. And basically, I was in charge of checking the rocket out before we sent it to the pad. So the rocket would come in different pieces. So it was a 3-stage rocket, so it would come in 3 main pieces, plus the fairing that goes around the payload, plus it had 9 solid rocket motors around the outside. So it would come in pieces, but the pieces that I handled were the middle part, the first and second stages. These were liquid fuel, so you could work around them without being in an explosive environment. The solid rocket motors and the third stage, because they had fuel already in them, it was a solid propellant like our model rocket engines. It was hazardous, and other engineers were in charge of those buildings. Mine was the first and the second stage. So we'd bring them in this building, and they were horizontal. It was like a big long garage, and then what we'd do is we'd hook up all the wires to them and all the pneumatic hoses and the hydraulic hoses, and basically the first stage was sitting here and the second stage was sitting right next to it, but because they were hooked with all the wires, they thought they were together. And so then we run a simulation, and everything, the computers would turn on and all the sensors would turn on, and we would check them out, making sure every sensor worked, making sure the hydraulics worked, and it would move the rocket engine around, make sure the pneumatics worked. There was pneumatics thrusters on the second stage that would pop, 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 pop. They don't just go psst, they go pop, 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 pop because they're trying just to fine tune the orbit. And so all that would be programmed in. We'd check it out and everything worked. Then we'd pull all the wires off and we'd put it on a truck and they would take it down to the pad. And since I did my job so well, they decided to move me from that Delta mission checkout to the launch up pad. And so then I was in charge of stacking the rocket on the pad. And so the first stage would come in one day, and then we would put all the solid rocket motors around, and that took 3 days because you could only do three per day. And then the second stage would come in, and we put that on, and then we put the third stage on. Then the satellite would go on top, and then the fairings would go around. And then again, we'd have to do another check to make sure that every sensor worked, make sure the pneumatics and the hydraulics worked. And then at that point, if the satellite was ready to go, we didn't test the satellite. That was somebody else's job. They would tell us they were okay to launch, and then we would proceed to launch. And then after the rocket took off, my job, at the time that I worked there, they had a blockhouse, and it was right behind this yellow building over here. And everybody was inside the blockhouse, but I was not. I was in charge of the pad, so I was down the road about a half a mile, which was actually the best place to be watching a rocket take off, because in the blockhouse, they couldn't see anything. They could only see it on a TV set. But we could see it really good. And it would take off, and then we would, the first people in were the fire department, because whenever it took off, all this grass around here, yeah, they'd start it on fire. So the fire department would come in, put all the grass fires out, and then we would come in, me and my crew, and we would secure the launch pad. Have to turn off all the fuels, because we were pumping fuel in. Well, without a rocket there anymore, we had to make sure that everything was secure, that there was no fuel leaking, all the pneumatics were turned off, all the water systems were turned off, all the purge systems, because a purge system is you're forcing inside to the rocket nitrogen, and because we were launching in Florida, there's so much humidity in the air, and humidity and metals, it causes corrosion. So you don't want your rocket corroding while it's sitting on the pad, so they pump in nitrogen and it flows throughout the rocket, and it forces out any water. So we'd have to turn all that stuff off. And it took about an hour to turn all that off, and so we're standing on this burnt launch pad. And this tower here that's so nice and pretty orange, it would turn solid black every time. And then a crew would have to come in and sandblast it all down. Because it's the weirdest thing, you know, what happens is the metal instantly rusts because it peels the paint off, and then there's bare metal, and you know, it's kind of like you sandblast some metal and you come back a few days later and it's all rusty. Well, this stuff would rust overnight. And so the crew would have to get out there pretty fast, sandblast it all down, repaint it, and then do it again. I don't know how SpaceX is able to do so many rockets. The way we did it, it took forever. So that's kind of what I did on the Delta program, and I worked there from 1988 to 1991. And we were launching one rocket a month. We had 2 launch pads. SpaceX, I just heard this morning, for next year, they're going to try to do 140 rockets. So it's like one every other day. It's going to be awesome. I'm amazed by SpaceX is they're killing the industry. There's nobody that can compete with them. I was watching another video on that. You know, all the people that are trying to do small sats, they can't afford to at the prices that SpaceX is charging. They can't compete. I guess Maximo asked what's an exoskeleton, and an exoskeleton has, you know, it's skeleton on the outside. It's hard shell on the outside, and all the soft stuff is on the inside, where we have the hard skeleton on the inside, and then the soft stuff surrounds it. All right. So it's about 3 o'clock, so I guess it's time to stop. I guess I'll switch over to my desktop cam. So you got a little bit of history of me when I worked at Cape Canaveral. It was fun. I enjoyed it. I love Florida. I would go back easily, but we have Apogee here in Colorado, and Colorado is just as great as Florida. They're great places to live. Florida, you have the beach. Here we have the mountains. Florida this time of year, October and November is like the best time of year. I'm kind of wishing I was back there right now. My daughter also lives in Florida, so I'm trying to schedule a trip out there sometime soon so I can enjoy the nice weather, because this time of year it's not so hot there. Summer times are pretty brutal. I don't mind the heat. So for me, being hot and sweaty in the summer times, it didn't matter. I don't like the cold weather so much. So in Colorado, when it gets bitter cold in December, it's pretty, but it's cold. Okay, so we will be back next week again. I should be here. Yeah, so it's like today is the 20th, so that must be October 27th. I'm not going anywhere, so we'll be back. I'm going to be flying rockets tomorrow. I'm hoping that you're going to be flying rockets on this weekend too. It's going to be nice here in Colorado. If you're in Colorado, come down to Pueblo. We have, that's the SCORE Launch Club. That's where I fly. It should be a great day tomorrow. It's going to be in the 70s, clear, sunny skies. I'm looking forward to it. It's not going to stay that way forever. It's going to get to winter here soon. So, until next time, I'm going to give you a countdown, and then we're going to close out. So 5, 4, 3, 2, 1, go out and launch something.